Our next presenter is going to be talking about what Bedrock rocks, project overview, roadmap, and deep dives. And it's presented by Dirk and Brenda. Dirk is an engineer working on Boost for the Bedrock team at Protocol Labs. Previously, Dirk worked on the BitSwap protocol in IPFS and on the JS IPFS team. Dirk was born in Zimbabwe, grew up in Indonesia and Australia, and has worked all over the world at different size companies, from small startups to Amazon.com. And Brenda is a product manager at Protocol Labs, working primarily on Filecoin and data onboarding. Before this, Brenda worked on a few different products at Microsoft, including Azure Machine Learning and Azure Blockchain, and built programs for Azure's global and data center expansion. Let's welcome them and let's give them a round of applause.
Hello. Hey, everyone. It's nice to meet you all. Thanks for the intro. We actually have two other folks joining today, Hannah Howard and Andrew Gillis, both of who are engineers on the Bedrock team. And I will share my screen really quickly. So let me know when you can see my screen. Oops. Okay. And great. So let me just go through a quick overview of what the Bedrock team does, as well as some of our projects. And then, and then we'll kind of talk through the different areas that we're working on. And then Andrew and Hannah will do some demos and deep dives of the different projects that we're working on. And then Dirk and Anton actually had pre-recorded a video, so you'll be seeing that as well, since they weren't able to join during this time. So first of all, team overview. What is the Bedrock team? I'm not sure how many of you guys know the Bedrock team, but we are a team at Protocol Labs that really focuses on building out the foundational components for Filecoin storage and retrieval. So on the right-hand side, you'll see a wonderful diagram of the awesome members on our team. Our team is led by Jacob and Lauren, and you see all the team members below them. In terms of actual composition on the team, we have a couple of product managers. So that's going to be myself, Hong Hao, and Marina. And and then the rest of the team is all engineers. So in case you're wondering about our different roles, that's kind of how it's split. And in terms of our current projects and teams, I think some of you guys have heard of the ones that we're working on, but we have Boost, which is Filecoin markets, and the tech lead there is Dirk, and the team is Anton and myself. We also have the Indexer project, tech lead there is Will, and the folks on the team are Andrew, Massey, and Hong Hao. And then for retrieval enablement, tech lead is Hannah, and leading Rod, Kyle, and myself. So this is just a really quick overview of our team. Let's dive into the projects. So Boost, what is Boost? So for those of you who might not know, Boost is basically a standalone replacement for Lotus Markets subsystem. So any of the markets capabilities that was originally in Lotus Markets are going to be handled in Boost, which is awesome. And with Boost, you also get better visibility into your system with this great new web UI that's previewed on the right. You also get more options for data transfer. You get more tooling support with a bunch of commands for car file copy generation and deal making commands as well. And for those of you who are using S-Jury or BidBot to make deals or to receive deals if you're a storage provider, They're actually, Boost has been integrated with these two tools, and so you can use it today. Really quick on some updates in terms of what we've been working on. So as of mid-June, we've officially launched. So highly encourage any storage providers and clients to upgrade to Boost and give us feedback. Or if you are running into any issues, you can ask in Filecoin Slack in the channel Boost Help. And in terms of roadmap, there's a couple of things that we're working on around scaling Boost. We would really like to understand from storage providers, what are some of the main limitations that you have when you're doing data onboarding, especially around the market's capabilities? And then in terms of enabling retrieval transports on Boost, we're looking at HTTP retrieval as well as BitSwap retrieval. Here's a link with some resources for those that are interested. I will share this with the event organizers later, and they can send out this deck. All right, and then really quickly on to the next project, which is Indexer. For those of you who might not know what the network indexer does, it's basically the indexer node is a separate node on the Filecoin network, and it basically is responsible for storing CIDs to storage provider mapping. So it's really important because it enables content discovery for the Filecoin network. So currently as a client, if I'm going to store some data on the network, I basically have to remember information about the storage provider. And so anyone who might not know exactly have all the details in terms of like the CID that I stored, they won't be able to find it. So what the indexer does is basically you can look up a CID and it will give you details around which storage providers to go find this data from, since they're the ones that stored it. So that's really neat. And right now the indexer node actually indexes both IPFS and Filecoin content. So, if you're looking for any content on these two networks, you'll be able to find it via the indexer. And right now, in terms of the indexer node that Protocol Labs is running, which Andrew will be able to share more about later, but we have indexed around 6.51 billion CIDs with 123 storage providers content there. And we actually have 4 indexer nodes running. So really want to shout out the awesome partners that have been running indexer nodes. Thank you for working through that with us. And we're actually looking for additional partners to help decentralize this as well. So right now we have 4, looking for more. So please do reach out if you're interested in running an indexer node, whether it's a full replica or a subset. And some updates in terms of what's been going on with the indexer project. So we've been running the indexer node and testing and doing scale testing in prod for a couple of months. And we actually just recently had an indexer sharding and decentralization workshop. So thanks for everyone who participated and joined in the great discussions there. If I understand correctly, I believe there's going to be further discussions at the IPFS thing in maybe a week or two. So continue discussions there. Thanks for the input. And the indexer FIP has been published, which is awesome. Thanks everyone for the input as well. In terms of roadmap, we will be looking to pretty much scale the indexer to petabyte scale in early Q3, a lot of the work around decentralization as well. So looking to onboard more partner nodes in the following quarter. We're also looking at sharded federation and further scaling. So lots of scaling work happening here. Here's a quick slide on some resources in terms of if you want to ask questions, where to find docs, and where to find our code. Great. And then our newest work stream around retrieval enablement, which Hannah will also share the journey as well in terms of the work that we've been doing here. So really quick updates in terms of enabling better retrieval enablement. There's lots of work going around that Hannah and Rod have been working on in terms of improving the data transfer mechanisms. So there's lots of improvements and refactoring to Go data transfer that's happening. Thanks Hannah and Rod and Kyle for the great work there. There's also a huge effort to stabilize auto retrieve, which is a service that we're running to get baseline metrics around retrieval reliability, retrieval success rates. So lots of work going on there as well for the past couple months. And then in terms of roadmap, we're looking to operationalize auto retrieve, really get it more stable, figure out a good cadence in terms of like operating it. And then we're also looking at retrieval requirements for Evergreen and Saturn in terms of, and this is specifically for retrieval from storage providers. So if you're a client looking to retrieve from a storage provider, or maybe you're a retrieval provider looking to retrieve from a storage provider, or a storage provider retrieving from a storage provider, all of those types of use cases are the ones that we're looking at. We want to make sure are super reliable. Resources. So some resources here around where to find us on FilePoint Slack. So there's a data transfer Slack channel that you can ask all your data transfer questions around, and also an auto retrieve Slack channel, and some GitHub links also. Awesome. So thanks everyone for hearing me talk at you for couple minutes. And I think we can go ahead and jump into demos and deep dives. And so I think, yeah, take it away, Andrew. So we'll start with you first, and then we'll move to Hannah after.
All right. Hi, I'm Andrew Gillis. I am one of the developers on the Bedrock team working on the Indexer project. And I'd like to go ahead and take you through sort of what a little more detail on what the Indexer is, where it fits in, and just show you some about how it works and open it up to questions. So let's get started. I'll go ahead and share my screen here and go ahead and share. All right. All right, I can see in the projection that you can see my screen. So I'd like to talk a little bit about where the Indexer fits in and everything first, just to give you some context. So as Brenda said, the Indexer is a piece of our infrastructure, which is responsible for keeping track of where content is located. That means who has it and how do you get it. So if we look at the diagram here, this shows a general overview of the various pieces of what the indexing ecosystem looks like. Main parts what we're talking about, of course, the indexer nodes, but they're just a piece of it. Storage clients store data on storage providers. Storage providers announce that they have content to the indexers. The indexers get the information about that content and store information about that content. So that means mapping CIDs or multi-hashes to the individual pieces of data that describe the content and where it's located. So the indexers then can use that to look up that data for a retrieval client. And a retrieval client will ask an indexer by CID or by multi-hash, hey, where's the data? And who do I get it from and how do I get it? And the indexer will then be able to furnish the reply, which says where that data is located. In other words, which storage provider, what are their addresses, and how do you get it? In other words, what protocols does that storage provider support for retrieving that information? And then finally, of course, the retrieval client can then go to the storage provider as directed by the indexer and retrieve the content that they're looking for. So the indexer is not a search engine. We're not doing anything like looking up keywords or information about the content. We're simply identifying where the content is as identified by content IDs or the multi-hash portions of those content IDs. So let's talk about what it actually looks like. I'm going to show you a very rudimentary UI. This is more of a placeholder until we have our actual web page in place. And this is just going to show you that we're looking up information. As far as the actual retrieval will generally be done by a retrieval client. In other words, you won't actually be seeing the raw content come back from the indexer, but rather a retrieval client will retrieve the index reply and then use that to go look up the actual content one is searching for. But let's just go ahead and look at what the indexer replies to the retrieval client. So we'll use this simple UI to show it. Here's just a sample CID. Let's go ahead and look it up. And we can see that the indexer has found it. In fact, it found it in a number of places. It's found it has, looks like, about 6 different places it's found it. And if we look at what it's returned, it says, well, here's the peer ID of one of the storage providers that has it. Here's the multi-address or maybe multi-addresses in the case of some of these of the storage provider. And here's information about what it is that was actually stored. So that's just an example, not terribly interesting from a user interface perspective, but if you were writing a client to find data, this is exactly what you'd want. Let's talk about some of the scale that we're running at now. So here are some graphs that describe some of the scale.
Andrew.
This is actually the last.
Andrew, really quickly, I think we might not be able to see like the graph that you're showing.
I shared. Okay, let me.
I think you might be sharing a different screen or something.
Yeah, we see just a static screen with your terminal and a little.
Wow, that's.
There
okay.
you go.
Awesome.
Okay, yeah, I guess it locks it to a particular screen. Let me go ahead and stop sharing and then reshare this for a second. All right, sorry about that, folks. Okay. Go ahead, reshare on this. Okay. Not sure what happened with the sharing, but I think, all right, we've got back to the diagram, and then we saw the UI, I believe. I'm not sure if we saw this or not, but here's the UI that returned information I was talking about with the pure IDs, multi-adders, and then information about what was indexed. And let's go over to these graphs. Let's see. There we go. Okay. Now you should be able to see the graphs. So this describes sort of what we're indexing. This is just for the last 6 hours. So we can see even in the last 6 hours, we've indexed 2.9 million individual indexes on multi-hash mappings to provider information. If we actually look at the last month, we can see that we have about 6 billion. We're indexing about 20% of the providers. That's 125 providers. It's only about 15.4% of the deals, so we're still ramping up. And if we look at the size of just the file size it's taken to index all of that, we can see we have it about, where'd it go? Here it is. It's about 3.25 terabytes right now to have all that information indexed. And this is, I know we said we had 4 nodes running, but let me be a little more detailed about that. So we do have a couple development nodes and a couple production nodes. Our production nodes are actually duplicates of each other, so that's not yet split over the node. So we have all of the indexing content, everything running on a single node. So we have an extremely efficient and specialized storage system. And the next phase is to be sharding that over as many nodes as we want to. And that will allow us to scale up to any number. But this shows that we can still, and with plenty of breathing room, have everything on one node currently. We just have duplicates for making sure we have good uptime and redundancy. So let's look at what we have a little more detail. Like I said, 6 billion multi-hashes. We can see we're currently getting pretty good ingestion rates if we look at the number of announces. Sorry to be scrolling, I'm looking for. So we see the announcements. Let's go to the previous. Let's go look at the last 6 hours. It gives us a better picture. So in 6 hours, we can see the second chart right here. We're receiving announcements pretty much constantly. Announcements mean, hey, I have more data to index, and the index will go out and retrieve the chain of information associated with that announcement, pull that in, and index the content associated with that chain. That means that we're getting all of those multi-hashes that pertain to usually a deal that's come in. Sometimes with NFT providers, it may be a single NFT or a few that are being announced every second. And so we have a pretty constant churn of activity, continuously growing our content, our indexed content. We just had a number of other stats, and we can see here over the last 6 hours, you can see pretty linear growth. If we look at a larger scale, that'd actually be more of a sawtooth as garbage collection takes it back down, and then it slowly grows. So if we look at the larger scale, let me go back to the last month. Here's our indexer growth over time. So you can see it's growing at you can kind of map the line through that, but the growth rate looks like it's increasing. as it should be. We're indexing more and more data. And the next, so we have some other interesting stats here. I think that if we look at uptime, look at response times, we can see that we have very fast response times within usually about a millisecond. Let me scroll down here. Response times, yeah, they're almost all within under a millisecond. So like I said, one node is really not working too hard to provide all of this indexing so far. And our next phase is scaling, be able to shard this across any number of nodes, but also be able to distribute indexer deployments to different locations rather easily, not have to have them re-index everything from the original providers, but be able to bootstrap them rather quickly with index information that they can learn from existing indexers. So in addition to that sort of that development, the next steps are also to provide more integration with being able to look up IPFS content using the indexers as well as IPFS itself. So being able to have much better integration along those lines, being able to index all of the rest of our providers, and then being able to share the indexed information with other indexers as they come online. So a couple other things to see. A couple other things to look at. Let me go back to the diagram here. Indexers can also share information with each other. They can learn about each other's providers. Here's a quick demonstration. I have a local indexer running. It has nothing in it. I just started it up. It has no data, but I can make it quickly learn about the providers of, let's just go to our main indexer. So I have a command here on the command line I'm going to run just to import providers. But let's see, import providers. Let's see, here it goes. And command's completed. Let's go refresh. And then now you can see all 124 providers that have just been imported. So in addition to being able to share provider information, they can also be able to rebroadcast information. So indexers support HTTP interfaces as well as libp2p interfaces. And if an announce comes directly over an HTTP request to a single indexer, that indexer is also able to rebroadcast that to all the other peer indexers that it knows about. And those indexers then can also receive that announce message and then go ask the original provider for the index content as well. There's a lot of documentation that we have on our GitHub site, and we're currently in the process of creating a more formal documentation, a separate documentation site, and we will be able to provide those in the very near future. But in the meantime, invite anybody who's more interested to look at our public GitHub repositories, and certainly to post questions to our team, and we'll be able to answer, get the information you need, and we'll be happy to provide any integration assistance that may be interesting. So at this point, I'd like to open it up for general questions, or if there's anything that you'd like me to go into more, I'd be happy to do so. And if not, I will hand it over to the next presenter. And just a reminder, always willing to field any questions as they come along. And I think Brenda will be able to give you the proper locations to send those questions to. Thank you very much. Next presenter.
Should I start?
Yes.
Hey, everyone. Hold on one second while we have a quick screen sharing swap up. Here we go. Okay. All right. Hopefully you all can see that. Yes. So hi, everyone. I am Hannah from Bedrock, and I'm the lead on the Bedrock's newest red-headed stepchild team, the Retrieval Team. And our goal is that we want to make retrieval from FilePoint storage providers faster, more reliable, and more configurable for you, the developer, or storage miner or a storage provider or whatever you're doing on the network. So I want to give you, before I get started, I want to give you a little bit of context on how Filecoin retrieval works and the history of its development. When we originally shipped Filecoin, we knew our network needed to obviously support retrieving data. We wanted people to be able to, who were retrieving, to be able to verify that they got what they asked for. And we knew that while a lot of the data would be free, we wanted to allow providers to charge for retrievals, and the payment mechanism should be trustless. So Filecoin mainnet shipped with support for retrieval over the GraphSync libp2p protocol, an incrementally verified data transfer protocol that supports partial retrievals via a mechanism called IPLD selectors. We also support payments through Filecoin payment channels. Once you set up a payment channel between two parties on chain, they can securely send payments to each other without the need for further transactions. And this is really important in order to do a retrieval quickly. Finally, between GraphSync and the payment channels, we've set up a mechanism for relatively trustless payments between the provider and the retriever, as they essentially exchange a series of incremental payments for data. Yeah, so that's it. And I'm sorry, hold on. That's the retrieval, and it basically works. The building blocks are there, and the retrievals are happening from Filecoin storage providers on our network all the time. But there is some room for improvement. We have work to do to enable all of our providers to be able to serve fast, high quality retrievals to lots and lots of clients at once. And that's what we're trying to do. So how do we get there? Well, probably when I said when we need to make an improvements, a lot of you in the audience thought to yourself immediately, yo, it would be fire if you could decouple transport from payment exchange. Actually, that's probably not what you thought, but that is one of the key long-term foundations for retrieval, is that we need to decouple the ways we transport data from the ways we pay for it. So I want to talk about why this is actually critical, so that you can understand why this has been a big focus of our efforts up till now. Let's talk about the differences between these two types of operations. A transport is a protocol to move data from one party to another. So as I said, we ship Filecoin with GraphSync as our retrieval protocol, but you might want to use something else, like for example, BitSwap, our other libp2p transfer protocol. Or maybe you want to jump out of the libp2p ecosystem entirely and use HTTP. Or maybe you want to think even farther outside the box and use an older protocol like USPS. In this case, I mean the United States Postal Service, aka the mail. Or maybe you are someone who thinks about transport protocols and wants to develop an awesome new way to move data that we haven't yet thought of. Either way, no matter what you're doing, you should be able to implement new transports without having to give up support for payments. That's the other half of the equation, exchange. How do you exchange payment for verified data? And there are a lot of ways to do that. As I said, Filecoin ships with our initial payment channel implementation. But already we're working with payment channel researchers on a much more performant implementation that makes use of the FIL. Maybe in your retrievals, you need payments to be flowing through lots of different parties. Or maybe you want to pay in some other token or even fiat currency and do credit card payments. Finally, there are alternate ways to exchange payment for data than the one we do currently. You could, for example, send encrypted data and then pay in order to get the unlock to that encrypted data. Either way, you should be able to write a new payment mechanism for our retrieval and know that it can run on any transport. So decoupling enables payment and transport. It enables people to experiment with payment and transport, and it's critical to our network development. It's important for independent, decentralized experimentation. If I want to write a fast data transport, I don't need to understand payments. And if I want to write new payment mechanisms, I don't have to understand transport protocols. So we've known for a long time this is important. And decoupling is a hard engineering problem. We didn't entirely know how to solve it, but we knew it was important. So even in the launch version of Filecoin, we took a shot. We included a library called Go Data Transfer to decouple transport from payment. So did it succeed in doing so? This would be where the Morgan Freeman voice says it did not. Not really. It's ultimately very coupled to the GrassLink transport protocol. It's a bit hard to work with, and it ends up adding more complexity than it removes. But we've learned a lot since network launch. We've made some big improvements to GrassLink. We've gotten a lot of feedback from other teams using our libraries, and from supporting miners doing retrieval. I wrote most of the original implementation of Go Data Transfer, and the feeling that it didn't really do what we aimed for has been a source of personal disappointment. But we decided to take a page from the Bible of Aaliyah, and we're going to dust ourselves off and try again. Now we are on the verge of releasing Go Data Transfer v2, and I'm really proud of it. And I want to talk a little bit about what's changed. First of all, we've made it much easier to work with. Writing exchange protocols for Go Data Transfer v1 meant implementing a lot of things, these validators, read validators, tracking lots of transport specific data in the exchange layer, and it apparently was sufficiently complicated that no one's tried to do it besides us, to write their own exchange protocol. So that's a bummer. In Go Data Transfer to v2, we've cut things down significantly. Exchange protocols they just need to implement a single validator interface and that has 3 methods, and that's it. Secondly, another big change we made for people writing exchange protocols is that we removed the requirement to build completely synchronous hooks, basically have to jump in and tell data transfer to pause at just the right moment in order to ask for payment. Now we let the exchange payment layer just tell data transfer up front what its data limits are before it's going to ask for payment, and then data transfer will asynchronously pause the request when the limit is hit. Our whole design now aims to let the payment layer respond in its own time to the events that happen during the data transfer. We never want to end up, we've had a lot of trouble with race conditions, and so we've really built this architecture around never having a race condition where the state of payments and the state of transfer get out of sync. But probably the biggest change is happening under the hood. To support multiple protocols, we need to interact with the actual transport at a much higher level. You should not, going through the main core data transfer code, see the words libp2p or network anywhere. And that's what we've done. That is essentially what's changed. We've moved a lot of complexity around the events that happen in the course of a data transfer. They're now all handled in the transport layer. So it's much simpler and more straightforward to implement alternate transports to GrassLink. Because in Go Data Transfer v2, Go Data Transfer cares a lot less about how the underlying transport works. That's really not all. There are actually so many different little quality of life improvements in Go Data Transfer, really a whole lot of improvements. I'm not going to go through all of these, but one thing I do specifically want to call out is we had some bizarre interfaces around our validation vouchers that are now completely replaced with our core IPLD library called Go IPLD Prime, and that meant some big changes and improvements in Go IPLD Prime. And I just want to acknowledge my colleague Rod Vag, who did some really awesome work on that. So what is coming next for our retrieval team? Well, we're going to take a brief break from all of this forward-thinking stuff and spend some time just focused on stability for our retrievals using our existing protocols and payment mechanisms, because we know this has been a long-term challenge for folks around stability with retrievals. And there's going to be a lot of efforts that we're pursuing. We do want to use this auto retrieve program to start to measure the success of retrieval at scale. We know that we need to build some diagnostic and repair tools into Boost because a lot of the time the problems with retrievals actually happen before the retrieval occurs, because something's gone out of state, gotten out of date with the storage provider state around the deals that they have. They don't have a record of where, say, a piece is or something like that. We do also want to support HTTP piece retrieval, and this is specifically for the use case of people renewing deals. If I am a storage provider who simply wants to get a deal from another storage provider in order to keep it renewed and essentially living in perpetuity, I should be able to transfer the entire piece over HTTP with the sort of set and forget type of approach. We are also going to be building client retrieval tools for Boost that hopefully allow you to do a sort of universal retrieval no matter what protocols are supported. And other things TBD. We are a new team. We're sort of like we've been working on this Go Data Transfer a while, but the actual retrieval team as an entity is sort of new, and we're kind of like figuring things out as we go. Finally, towards the end of this year, we do want to come back and prove out this Go Data Transfer v2 implementation by doing something we wanted to do for a while, which is support bit swap retrievals and even mixed bit swap and graph sync retrievals, potentially with payments. Right now we have everything you can build in IPFS, and Filecoin has this kind of like Sophie's choice of having to choose a transport protocol with some tough trade-offs. And we would like it to be a much more why not sort of both type of situation. And it's not just about making choices easier. We can use one protocol to fill in gaps with the other. We should be able to move content address data over peer-to-peer protocols faster than Web2 using multi-party data transfer, but we'll need GraphSync and BitSwap to do it. We're figuring out how to interleave these protocols for maximum performance. Finally, if you want to know more, here's a ton of information. I know I'm over time, so I'm going to just wrap this up. You can find us at Data Transfer Interop on Filecoin Slack. You can check out these topics to dig in, and that's my handle on the different Slacks and Discords, and you can hit me up. So please don't hit me up in the middle of the night saying I'm a bad person because your retrieval didn't work. That's it. Thanks.
Awesome. Thanks so much, Hannah and Andrew. Next up, we have Dirk and Anton, who actually pre-recorded a video for Boost. And I believe someone on the FIL Swan team will help play that. I'm not sure if there's someone I need to talk to for this, but I sent over the video earlier today. So yeah, they're going to be doing a demo on Boost and some of the awesome things you can do there.
Hello, everyone. So we are going to do a demo of Boost. We recently launched Boost version 1.0.0. So now we are in general availability, and you're welcome to install and try Boost on your storage provider. So let me share my screen and we can go over the functionality of Boost. So the source code for Boost you can find under Filecoin project Boost. We are already on version 1.1.0. We have a documentation website where you can read more about Boost. We have a getting started page as a storage provider if you want to be providing deals with Boost, or as a client if you want to be storing data on the Filecoin network, as well as a lot more information about the project. So this is what the user interface of Boost looks like. We have the panel on the left with various menu boxes that Dirk is going to talk over. And the first thing you see is a list of your storage deals as a storage provider. So I'll quickly go to another screen and create a deal so that you see how it looks on the Boost user interface. So basically, I'm going to trigger a deal so that we store some data on that particular storage provider, which I'm currently connected to. And you can see that the data starts transferring and the deal just appeared in the storage deals screen. Dirk, do you want to take over and talk through everything that we see on the UI?
Yeah, thanks, Anton. So as you can see, the UI updates in real time as the deal is progressing. So at the moment, the first deal is transferring, the second one is in the ready to publish state. So if you look on the left-hand side in the menu, there's storage deals, and you've got a list of 384 deals and 8,000 legacy deals. Legacy deals are deals made with Lotus client. And now if you use the Boost client, you'll get regular deals. So we are planning to deprecate the Lotus clients towards the end of the year. So we encourage you to swap over as soon as possible. And you'll also find that there's a lot more features when you use the Boost client. So for example, if something goes wrong during the various stages of a deal being made, there's a retry button you can click to retry where you left off. So we're going to look at the detail of a deal now. Let's click into the one that's transferring. And you can see here that you've got all the details about the deal itself. And if you scroll down, you can see the logs for what's going on in a lot of detail. So if there's any problems with the deal, it should be easy to capture these logs and send them to us. To capture the logs, you go to the top of the page and you click on the clipboard icon. So let's go back to the main deals page now. So the second menu item is deal proposals. And so this just shows you a log of acceptance or rejection of deal proposals that have come in from clients. And again, yeah, you can click through to the actual deal itself. The third menu item tells us how much storage space we've allocated for downloading deals. And so as you can see, some of this storage space is being occupied by the deal that's currently being transferred. So if you accept enough deals that you go over the limit, from that point on, you'll reject any new deal proposals. And so this is sort of a way of providing back pressure so that you don't accept so many deals that you don't have time to seal them. Next on the left, we have the sealing pipeline. So this is a view into what's going on in the sealing subsystem. On the left-hand side, we have the sort of traditional regular deals. On the right-hand side, we have snap deals, and you can see how many deals are in each sealing state. Right now, there's no active jobs, but if, for example, the sealer is in PC1, you'll see the worker at the bottom of the page there under the workers section. So let's talk about funds. So in Boost, we have two source wallets. One is the wallet that you use for paying the gas cost for sending the published storage deals message. And the other is the wallet that is used as the source for deal collateral. So when a deal is made, the storage provider needs to put collateral into escrow. So this screen tells you exactly how much deal collateral is available in escrow, how much is locked, and how much is sort of tagged, is what we call it, for ongoing deals. So for example, at the moment, you can see that there's 929 nanofil tagged for ongoing deals. And once these deals have been published, the funds will move from the tag state into the locked in escrow state. The second wallet there you can see is a published storage deals wallet. And as I said, this is just the wallet that is used to pay the cost of sending the published storage deals messages, the gas cost. At the bottom of the page, there's a list of all the transactions that have happened, just so you can keep track of exactly what's going on with your wallet. If at some stage you need to move more collateral into escrow, you can click the bottom at the top, the button at the top, sorry, and it will give you a menu that will allow you to add, to move collateral from the deal collateral source wallet into the deal collateral and escrow wallet. Let's look at publishing a deal. So we have one deal that's ready to be published. So if you click on the Publish Now button, that's going to send it off. And after, I think, 5 confirmations, it'll show up as, well, so right now it's awaiting publish confirmation. After about 5 confirmations, it'll show up as being published. And let's look at deal transfers. So this screen just shows you how much data is being transferred for storage deals in megabits per second. And on the menu, we just have like a summary version over the last 10 seconds. What's the average transfer rate? Then we have the message pool. So this is not going to show anything right now, but occasionally we've seen problems where messages get stuck in the message pool. And so this screen just allows you to kind of see exactly what's what's blocking your messages if they get stuck in the message pool. And then finally, we have the settings page, and this allows you to adjust the price of your storage ask and some other parameters. And it also allows you to see all of the libp2p information about your node, the peer ID, addresses, and all the protocols that you're advertising. So you can see in this protocols list, there's one called fil/storage/mk 1.2.0. And this is the new protocol. So deals made over this protocol will appear in the deals lists that we saw at the beginning, and deals made over the previous protocol 1.1.0 will appear as legacy deals. All right, Anton, do you want to take us through how to make a deal?
So we already triggered one deal with the storage provider, and we're now publishing another one. Let me show you the docs website. Basically, one new feature that we've added is the GraphQL API. And this is useful because it allows you to query any information that we store related to Boost deals. So any information that you see on the UI, we store it in a SQLite database, and we provide the GraphQL interface, which you can access again on an HTTP endpoint. So the way that works is on the right side here at the top, you have a documentation panel, which basically shows all the different fields and queries that we support. If we add more functionality to Boost in the future, we'll basically be adding more queries here. And then you can paste in a GraphQL query and extract all the data that you're interested in. So for example, here under deals, if I'm interested in more fields around deal, I could just, for example, add them here with autocomplete. For example, let's say the start epoch and the end epoch, and we get all the relevant information returned back by the GraphQL interface. You can also copy this query and paste it into a curl command as described in the Boost docs page, and you can use curl to get the data from GraphQL. I think that's everything that we have prepared for today. Dirk, is there anything else that we would like to demo, or that's all?
No, I think that's it. Thanks, Anton.
All right. Thank you, folks. Goodbye.
Awesome. Thanks, everyone. That was our presentation from the Bedrock team. Really appreciate everyone joining today. And if there's any questions, feel free to reach out on Filecoin Slack. Thanks, everyone.